This was networking class, Cisco networking, and we're talking about subnetting. And this is Wednesday the 20th. We started off the class, we talked a little bit about cell technology and how you have, a certain number of frequencies inside the cells. So if somebody's in the cell and they call using cell technology, they get a frequency. So those frequencies start getting used up as people make calls inside the cell. So when you have something like a disaster or something, frequencies can get used up. Now, what we looked at was kind of cool. The Weather Service now works with cellular technology so that if there's a tornado, I'll try to draw a tornado. Okay, here comes the tornado. They can more accurately contact people, because what they can do is from a cell tower they can broadcast information out to the phones. They can send a text to all those phones, and you don't even have to sign up. The cell tower is just going to broadcast. So you're going to go to every phone that happens to be connected to that tower. So it really makes sense. Like these two towers are right in the path of a tornado, then those people can all be contacted quickly. Great idea. Alright, next thing, taking a look at IP addressing and version 6 and 4 and subnetting. Okay, we subnet version 4 to manage addresses, to have enough addresses to cover based on the shortage. Version 6, we don't have a shortage, so we subnet more on looking at network design, which is also used in version 4 too. So we took a look at an example here in which we have these routers, and we just made this up. So we have some company that has these routers in different locations, and they have this central router that's maybe connected to an ISP or something. So they need to network this. What makes sense, what we did was we said maybe this whole group over here would be a 1010 something something. Okay? So then this router, if it needs to send something to any of these networks, no matter how many are here, it can send it to 1010 whatever. So we only need one route here to take care of all this. Same thing here. We could call this one 1011 and maybe this one 1012. So then there's only 3 routes here to get traffic to the area it needs to go. And then when it gets to these routers, they can divide it up appropriately. And you can even do that within here, figuring out your addressing, to keep the number of routes in the router lower. So we look at this hierarchy or layers of networking to where we have access into our network and how traffic then can move throughout the network. The last thing we'll mention here, we did a little bit of an addressing example. Okay? Before I go into that, I'm going to just draw a line here. If you're looking at this, we did talk briefly about an IP6 address. So here's the first 64 bits. Here's the second 64 bits. We take that slot of 16 bits out of there to subnet. And then when you subnet that, you can subnet 1, 2, 3, 4. So in IP6, it's more about network design because you have more than enough addresses. And in IP6 also, if you were going to go into the interface ID part, the last 64 bits, most of the time if people subnet there, they use a whole nibble. A nibble is 4 bits. A byte is 8 bits. And a nibble is 4 bits. Anyway, so then you could take 4 bits and use those, and then this would be the mask. The prefix bits, I should say, too. Okay? Now, setting that aside, we have this example here on the right. We have, we counted them. We just made this up. So we counted networks and came up with 15. We've got these LAN networks. You can see them. We've got a LAN here, a LAN here, here. Okay? And then we have WAN networks. Okay, so here's a WAN, here. So we have 15 networks. And then, you know, let's say we're going to have less than 60 hosts on each one. Okay? So I took and I made up a public address. So I took a public address. This one probably belongs to somebody. And I said, we're not getting the whole Class B address. We're going to divide it right here. So that's where that /22 comes from. And so now we have 10 bits we can work with. So we said to get those 15 networks, we're going to cut it off as close as we could to that. So we took 4 bits and we drew our line. These 4 bits are going to represent our network. And then we wrote them out. Okay, I'm not going to go through all of that, but you know, the first one would be 0, 0, 0, 0. So those are all zeros. It's going to be a slash. We got, right, 24, 25, 26. So it's going to be a /26. So we have all zeros there. So the first network address would be this one right here. 180.80.00/26. Might be a little hard to see, but that's what it is. 180.80.00/26. Okay, got that from up here. The next one, if a 1 goes in here, I drew it in there, that's going to be one group of 64. So it must be the next one, 64. And then the one after that would be 128. Alright, so before I was interrupted there, and so we get 128, and then another 64 under that, 192, so we have in there 192, and then what's interesting, once you get past that, okay, that would be 2 1s there, then you're going to have what I have drawn here, 1 and 2 zeros. And there's where the change in the octets are. So this would be a 1, so actually that would be 180.80.1.0/26. Alright. And then you could go on from there. We'd get 16 different networks. And then the final thing, in order to do those WANs, you could take one of these 16 addresses, pull it out, then you have these bits to work with, and then you can do your division here. Now you have 2 addresses there, 4 bits there, so you can go 16 networks to cover those WANs because they only need 2 addresses each. And that's it. And we will, the pre-assessment is on, needs to be taken before Friday, and then we'll take the final assessment, the post-assessment on this on Friday, probably at the end of class. But we will start the next unit, next chapter on Friday too. And that's it.